child safety system, which all of us could use in the car seat, with a lot of safety features on it. So whenever you guys are ready, go ahead and start.
Okay guys, we're the automobile detection system. I'm Troy, this is Vishista, this is Aaron, and that's Chris. The project intends to revamp a deserted market by introducing new technology. Previous systems on the market only use single detection mechanisms, and that allows too much room for error in a child safety system. Our design uses multifaceted detection mechanisms to increase reliability to acceptable standards.
Okay, so our motivation for the project, mainly. So, how many deaths are too many? Since 2002, there's been over 800 reported unattended children deaths related to heat stroke or other causes. But the other half of that statistic are all of the instances where a child has been left behind or forgotten that has not resulted in a fatality. One of the bigger motivations was the introduction of the Hot Cars Act of 2017. This was actually voted on in June of last year. What it would do is require all automobile manufacturers to include some kind of unattended passenger safety system within all of their new vehicles. But for us, we wanted to basically create an aftermarket solution. Not everyone is either A, planning on purchasing a new vehicle, or B, has the means of purchasing a new vehicle with these safety features. So we wanted to provide a system for them that would offer the same level of safety within the vehicles for their children.
So our design requirements are quite simple when we break it down. We need to be able to detect a child when it is alone in the vehicle. We must monitor the internal cabin environment to make sure it's safe or unsafe for the child. We also must be able to communicate that information to the driver through preset triggers, as well as having a rechargeable power supply to ensure that it is always constantly powered, and lastly, to log data in case of emergency situations.
So our design flow is going to break down into 3 basic modes: standby mode, occupancy verification, and alert mode. In standby mode, our PIR motion sensor is going to passively scan for vehicle entry. After vehicle entry, a multi-threaded program will be initiated, triggering our facial detection software and the car seat module, which will pick up the weight of the child. Alert mode will basically be triggered only if the child is left inside the vehicle after the driver goes out of range with their Bluetooth device.
So for our main module, design implementation, we decided to use a Raspberry Pi 3. We needed the processing power for that. And specifically for our overall interaction, we decided to go with a multi-threading. We investigated both a multi-processing solution as well as a coroutine. And for us, a multi-threading allowed us to basically have all of our sensors running and provide asynchronous input to our main module for all of our conditional logic responses. We also, on the main module, have our passive infrared motion sensor. Basically what it does is it measures a change in the infrared radiation emissivity. So it has a set standard, and when something moves through, it detects that change. It's very sensitive to that. The output is a digital high or low, so it's either going to be a 1 or a 0. Pi camera, that's our main way of interacting with our facial recognition software. We can have either continuous or discrete image capture for our facial recognition algorithm. Originally, we were having a continuous capture, but we were finding that for our processes, it was a bit too computationally intensive, especially running our hard cascades, which is what our facial detection algorithm is running. So we set up a single image capture, but we set up multiple single image captures to ensure that in the event that the child is moving, it's blurred, or it's not a good image capture, we're not relying only on one basic image to run our algorithm through. And then finally, we have I2C device, which measures both temperature and humidity ambiently within the vehicle at the time.
So we will have two peripherals that will be able to send data back to our main module. The first being the car seat. Both designs are very similar. We decided on an Arduino Nano for both to communicate serially through using the Bluetooth HC06, which is a slave Bluetooth module. And with that, it uses a hub and spoke socket connection using RF comms to communicate with the main module. The force sensing the resistor, the FSR, is a little resistor pad that, as you press more weight on it, it increases the voltage. Using a voltage divider, we're able to send that data through an ADC to calculate weight and set that to a threshold weight that will set a flag, and that will send it back to the module, the main module. Similarly to the car seat module, we are using the same HC06 Bluetooth module. As I said, very similar to the car seat module, except now we are using a little vibration motor that, when you are out of range of the main module, it'll vibrate, and that will only really receive data as opposed to send and receive.
So for our phone app, we've designed the app in a way where it's very easy to set up and very minimal human interaction is required. As far as the frameworks are concerned, like we went with open source and hybrid cross-platform, which is we use Apache Cordova for that, which is a command line tool that enables us to package like standard web technologies like HTML, CSS, and JavaScript to be packaged and deployed as an application into our mobile devices. So we didn't really need to have any immediate mobile specific knowledge to begin with the app. Also, we use Ionic, which is built on top of Cordova, that enabled us to have a single page application framework, which is Angular, that enabled us to use some object-oriented paradigm in our design.
So we have a few videos going through some of our testing.
So this is basically the phone is connected to the main module, and as you can see, when it goes out of range, the Bluetooth connection is no longer there. So as you can see, if the Bluetooth range is not there, then I should get a notification, and when I click on it, it should say some info about whether the passenger is there or not, the temperature and all that.
So the next was taken from our test.
It wasn't supposed to be any sound in that one.
So it's essentially just taken from our tests of the.
As you can see, our camera also gets sound as well.
But it's just taken from our tests of our image capture. Basically just trying to have an output to detect whether or not we're getting a positive hit. Our system is basically a headless system, so if it's running correctly, you don't really have a whole lot of indication as a user. So a lot of this stuff we had to debug and build our own kind of debugging steps to ensure that we were getting a positive reaction.
So right here, we're just going to simulate our motion detector. You'll see a hand come down in front of the module in the bottom right corner. There it goes, and on the screen it says the motion is detected. Same thing with our FSR sensor. We're going to simulate that we can detect pressure.
So we have a certain range because it's actually reading an analog input. But through our own testing and load testing, we're able to determine a threshold. And anything that meets above that threshold, we'll consider a trigger.
So the project, we were able to successfully detect a life form in the vehicle with all the sensors that's out there. Also, all the subsystems that are working independently, we were able to integrate that with the multi-threaded stuff he was talking about, so that all the system works asynchronously at the same time. And we also have a prototype like casing build out that we are showcasing right now. We haven't been able to integrate all the modules in it yet, but that's how it's going to look like in our final design.
So some of the problems that we ran into, obviously, are software limitations. Specifically, running with our HAR cascade as our facial detection algorithm, there's a few drawbacks to it. Number one, it's more computationally expensive than something like LBPH, which runs histograms, or another algorithm like Fisher faces. Also, it does have some problems with lighting, and There's also another problem developed with skin tones. Because it runs a nearest neighbor calculation, and it's looking for contrast. When it's trying to build its classifiers, sometimes you're able to develop either false positives or false negatives depending on both lighting or skin tone of the individual. We ran across this when we were actually running it through our testing data. We were able to get our overall success rate through up to about 86, 87%. We think that if we were able to have more time with it and basically spend more time in-depth training, that we might be able to raise that up a little bit higher.
Another delay that didn't allow us to get a lot of testing done was to acquire legitimate 3D parts. All these were designed in-house by me. Late in the game, about less than a week ago, we acquired an industry-grade printer that allows us to print whatever we could think of. So this was a really nice piece that came out clean. When you're printing on consumer-grade printers, you really have to just print from the ground up. Any floating material will cause uncertainties in the print, and as you can see here, this thing is just a mess.
Sorry.
In terms of the hardware problems that we encountered, we originally went with an Flora, the mobile Arduino. Unfortunately, the Bluetooth protocol that it used, the GAP protocol, didn't really work for our needs, so we had to actually end up switching to the HC06 slave module that we were talking about before.
We also had a problem with our original GSM modem. What we found was the serial communication that the GSM modem that we chose used, it didn't really play nice with the serial communication that was available on the Raspberry Pi. Now the Raspberry Pi does offer a secondary serial bus, but the buffer size on that is much smaller, and so we were running into problems where we couldn't receive data on our Bluetooth device. We couldn't receive, we were getting basic data errors because we were getting overflows. So we had to choose a whole other GSM solution that relied on the serial connection through the USB instead.
And here you see our final development cost. We go line by line, but I'm sure everybody doesn't really want to hear that. So our final grand total comes out to around $334, which isn't bad if you are with what we were considering, which was talking to auto manufacturers and to implement it into their cars already, but buying it individually as a single household might be a little expensive.
Questions?
Will this also work for animals, if some animals inside the car?
So that's actually a good question. There's a really big market for that because it's a lot more common, I think, for pet owners to think about just leaving their dog behind in the car with them. There is training that you can rely on, especially with computer vision, to differentiate, to pick out something like a dog or a cat in a frame. That was something that we did want to look into. Realistically, with our time span, we weren't able to expand our project into that, but it was definitely something that crossed our mind. And it was able to be integrated with some of our other solutions. For example, like our motion detection would be very, I mean, those two systems would then be building upon each other. We would have had to, if a lot of pet owners kennel their dogs, for example, so for something like that, we would have to develop a separate module with a different type of temperature probe to work on that. But we could use still the same force sensing resistor inside the actual kennel for the weight.
Thank you.
So,
I see a lot of technical detail, and you guys have talked a little bit about costing and so forth. So the next step is it a viable product? You know, are you going to pitch this to a VC or an angel and get funded and do a startup and all that? For something like this, it seems like there's an issue with safety, liability, that kind of thing. What happens if your system, you know, doesn't process correctly and somebody gets hurt or somebody gets killed, right? I mean, companies go out of business all the time, like immediately with that.
True.
have you guys thought about that? I mean, it feels like there's some real value add to add redundancy and resiliency and, you know, other capabilities that would address that liability issue. And then you could take this product in and probably get it funded and, you know, set up a startup, right?
Right.
Yeah.
But they're gonna ask you about that.
Right. For what we have, that is actually one of the biggest concerns, and I think that's why we wanted to try and develop a redundant system. I think if we were to expand upon that, there's another type of redundancy that can be involved, and that's in something like a belt buckle,
Right.
because that's a lot more of a reliable connection.
Right.
So immediately off the top of my head, if I was to think about adding another concurrent system that would be involved with that, I think we would move in that kind of
Right.
direction.
But even rather than rushing into a solution, which is redundancy,
Okay.
address it at an even higher level, which is how do you solve the liability problem,
I see.
right? Maybe there are other ways to solve that problem that don't necessarily involve more hardware, more software, more technology. Maybe there's something about the design. Maybe there's something about the business model. Maybe there's something along those lines, right?
I'd like to chime in on that one.
Sure.
We have looked into, due to time, obviously we haven't been able to see our project all the way
Sure.
through. But there is OBD2 sensors that are universal across all vehicles.
Right.
And there are Bluetooth modules available that people can interface with their cars. So we thought about just simply cracking the windows or turning on the vehicle
Sure.
to start the air conditioning.
Right.
So see, I mean, interfacing to the vehicle's capability, right?
Right.
A buddy of mine did a big startup and made a bunch of cash, and he's driving around a new Corvette right now. And apparently, his kids asked to borrow the keys or whatever, and apparently there's like inward-facing cameras now. And so he gives his kid the key, and the system knows that it's the kid, and basically puts a throttle limiter on and tracks his motion, right? So he says, okay, you can drive this down to 7-Eleven and back.
Right.
And don't break any laws and don't break the speed limit. And of course, his son says, oh yeah, Dad, no problem. Right, and then, 2 blocks away, they're hearing the tire squeal. Well, anyway, that sensor system inside of the cabin, right, seems like something that you could link into. And
Definitely, automatic manufacturers have like those resources, like some of them already have similar technology to the FSR, like
Yeah.
having a little pad underneath the seat or a seatbelt buckle.
Right.
something like that. To also chime in on what you were saying earlier about liability and such, once again, if we had, I'm just answering your question with another redundancy system, which is if we had more time, we'd implement GSM modem, which we would be able to communicate with the emergency services, emergency contacts, so.
There you go.
Hopefully, I mean,
well, you can get that piped through the automotive
Yeah.
intelligence, right?
Yeah.
I mean, it's already there. Most cars these days have cellular, so.
So we're just trying to like obviously prevent fatalities, but
Right.
obviously we would get emergency services involved.
Yeah, great. Thanks, guys.
Thank you.